This morning at 4:10 a.m. Universal Time, astronomers captured something nobody expected. 7 distinct jets shooting out from 3I Atlas in multiple directions. Some pointing toward the sun, some pointing away. And the question everyone's asking, are these natural ice jets from a comet or are they something else? Because here's what makes this extraordinary. To produce the non-gravitational acceleration NASA measured, a natural comet would need to lose 10 to 20% of its mass. But if you have jets firing in many different directions, only a fraction of that mass creates thrust in any single direction. Which means either this comet is losing way more mass than any model predicts, or the jets are doing something natural comets don't do. Avi Loeb put it simply this morning. Is the network of jets associated with pockets of ice on the surface of a natural cometary nucleus, or are they coming from a set of jet thrusters used for navigation of a spacecraft? We do not know. Good morning. What you're about to hear is based on observations released within the last 12 hours. Fresh images, live debate, and a question that's dividing the astronomical community right down the middle. This is the most detailed look at 3I Atlas since it emerged from behind the sun, and what it's showing is raising more questions than answers. Before we dive in, if you want to stay on top of this rapidly developing story, hit subscribe and turn on notifications. December 19th is 41 days away, and that's when we'll get definitive answers. Your subscription helps us continue this coverage. Now let's break down what just happened. At 4:10 Universal Time on November 8, 2025, 3 astronomers, Monsieur Yeager, G. Raymond, and E. Prosperi, captured stacked images of 3I Atlas. 24 exposures in green filter, each lasting 35 seconds. 2 exposures in red, 2 in blue, and what they revealed is stunning. A large glowing halo extending out to 500,000 kilometers. That's 5 arc minutes in the sky. For perspective, that's larger than the full moon appears from Earth, but spread out and diffuse, requiring long exposures to detect. Within that glow, at least 7 distinct jets. Not a single plume, not 2 symmetric jets like you'd expect from a spinning comet with active areas on opposite sides. 7 separate structures, each pointing in different directions. Some of these jets are anti-tails, pointing toward the sun. We've talked about 3I Atlas's anti-tail before, that unusual sunward jet visible in Hubble images from July. But this isn't one anti-tail. Multiple jets are pointing sunward. Multiple jets are pointing in other directions. It's a complex network. Now here's the physics problem this creates. NASA's Jet Propulsion Laboratory confirmed non-gravitational acceleration. The comet is being pushed off its purely gravitational trajectory. For a natural comet, that push comes from outgassing. Ice turns to gas, shoots away from the surface, and Newton's third law pushes the comet in the opposite direction. But if you have jets firing in many directions, the forces partially cancel out. Only the net thrust in one direction creates the measured acceleration, which means the total amount of material being ejected must be much higher than the 10 to 20% Loeb calculated. Loeb addresses this directly in his analysis published this morning. Given that a large number of jets appear in many directions, the reported non-gravitational acceleration of 3I Atlas requires much more than 10 to 20% of its initial mass to have been evaporated. Think about what that means. If the acceleration requires 20% mass loss from a single jet, but you have 7 jets pointing in different directions, you might need to lose 50, 60, maybe 70% of the comet's total mass to produce the observed acceleration. That's unprecedented. No known comet has ever lost that much mass and remained intact, unless, and this is where the alternative hypothesis comes in, unless the jets aren't passive outgassing from solar heating, unless they're active thrusters providing controlled navigation, because a technological propulsion system can produce thrust with far less mass, ejected at much higher velocity. If you're finding this as fascinating as I am, please take a second to like this video. It genuinely helps the algorithm show this content to more people interested in these developments. Loeb doesn't claim this is proof of technology. He's asking a question. He writes, Technological thrusters could give the object a boost with much less mass jetted out at a higher speed. It's not a conclusion. It's a possibility that the data doesn't rule out. Last night, Loeb appeared on News Nation's Banfield program, and the host asked him directly, "Is 3i Atlas revving an engine?" Loeb's response was careful but pointed. There was some propulsion that moved it away from its original trajectory, and I would have expected it would lose 10 to 20% of its mass as a result of the recoil. The interviewer pressed, "Could an engine explain the blue color the comet showed near perihelion?" "For a natural comet, this blue color is very surprising," Loeb said. "It could potentially be explained by a hot engine or a source of artificial light. However, it might instead be a signature of ionized carbon monoxide for a natural comet." Notice the structure of that answer. He presents the technological possibility first, then immediately offers the natural alternative. He's not claiming it's artificial. He's saying the observations allow for both interpretations, and we need more data to distinguish between them. This is where scientific methodology gets interesting, because the default assumption in astronomy is natural origin. When you see something unusual, you look for natural explanations first. Most of the time you find them. Occasionally you discover new natural processes you didn't know existed. But what happens when you have multiple anomalies that each require improbable natural explanations? At what point do you seriously investigate alternative hypotheses? Not because you believe they're likely, but because the scientific method demands you remain open to what the evidence shows. The Counterargument Dr. Ken Gayley, an astronomy professor at the University of Iowa, appeared on Live Now from Fox yesterday to provide the mainstream scientific perspective. And it's important we hear it. We would always start off with the assumption that these are natural objects, and we would study them in that way, Gayley explained. And if there's really very powerful evidence that they're not, then we might be led toward another direction. But for now, there's still plenty of evidence that these are potentially just completely natural objects. He's right. The burden of proof for an extraordinary claim is high, and that's appropriate. Most astronomical phenomena have natural explanations. The default assumption should be natural origin unless evidence conclusively points elsewhere. Gayley emphasizes that 3i Atlas formed in a different star system, under different conditions, potentially billions of years ago. The chemistry, the structure, the behavior could all be natural but unfamiliar because we've never encountered objects from other stellar systems in detail before. We have a sample size of 3. Oumuamua was strange. 2i Borisov was normal. 3 Atlas is strange in different ways. With 3 data points, we simply don't know what the range of natural variation looks like for interstellar visitors. Multiple jets aren't impossible for natural comets. They happen when a nucleus has multiple active regions. When rotation exposes different icy patches to sunlight at different times. When subsurface cavities create pressure that breaks through the surface in unpredictable ways. The blue color near perihelion could result from extreme solar heating, creating ionized carbon monoxide. Exactly as Loeb mentioned, the missing massive debris cloud could be explained by unusual dust particle sizes, or extreme dust-to-gas ratios, or viewing angles that hide the tail from our perspective. Each anomaly, individually, has possible natural explanations. The question is whether the accumulation of improbabilities eventually demands we seriously consider alternatives, and scientists disagree on where that threshold lies. Let's be clear about what we're looking at. The November 8th images show complex jet structure. They show activity. They show a comet that's clearly outgassing, clearly releasing material into space, clearly active despite being 1.38 astronomical units from the sun. What they don't show is a massive, prominent debris tail like Comet Lemon displayed. The November 5th Lowell Discovery Telescope image, released 2 days ago, showed 3i Atlas as a bright ball of light with faint glow around it, akin to an atmosphere or a coma, but no clear evidence for a cometary tail. The caveat is important. When these images were taken, 3i Atlas was only 13 to 29 degrees away from the sun in the sky. If there's a tail pointing away from the sun, we're looking at it nearly head-on. like looking at the headlights of a car driving straight toward you. You see the bright source but not the road behind it. In the coming weeks, as 3 Atlas moves farther from the sun's position in our sky, the viewing angle will improve. If there's a massive tail, we'll see it clearly. If there isn't, that strengthens the anomaly significantly. November 11th, just 3 days from now, marks when the comet reaches 30 degrees separation from the sun. Amateur astronomers with 8-inch telescopes will start observing it in the pre-dawn sky. The question everyone will be asking, is there a tail? A real prominent, undeniable cometary tail matching the calculated mass loss? If yes, mystery solved. Natural comet with unusual but explainable characteristics. If no, we have a serious problem with our understanding of cometary physics or the nature of this object. 41 days from today, 3I Atlas makes its closest approach to Earth. 168 million miles, 1.8 astronomical units, completely safe but close enough for detailed observation. Between now and then, we have an unprecedented opportunity. The Hubble Space Telescope is scheduled for ultraviolet spectroscopy to determine gas composition and sulfur-to-oxygen ratios. The James Webb Space Telescope will perform detailed spectroscopic analysis in December, looking for any unusual molecules or unexpected chemical signatures. Ground-based observatories worldwide will track the comet continuously. The International Asteroid Warning Network's Special Observation Campaign, which began November 27th, will coordinate data from dozens of facilities. Professional and amateur astronomers will contribute observations to the Minor Planet Center, and will finally answer the tail question. If massive outgassing occurred during perihelion, December observations will show evidence. An expanded coma, a developing tail, measurable changes in brightness and activity, something. If we see nothing unusual, if 3I Atlas remains a compact fuzzy ball despite calculations requiring massive mass loss, that's when the scientific community will have to seriously grapple with what's happening here. The inspiration factor. Here's something remarkable that's happening alongside the scientific mystery. Loeb published a message 2 days ago titled, "The Inspiration Delivered by 3I Atlas to Our Doorstep." He shared that he's receiving hundreds of emails from around the world. Not from scientists, from regular people, parents, students, kids. One message from Mexico. "Every day my son asks about the latest news from 3I Atlas. He told us he would love a telescope for Christmas." Another from Toronto. "I'm a chemical engineering undergraduate. I can't remember the last time I was this curious or inspired about anything. This is what science is supposed to do. Inspire curiosity. Make people look up. Make children ask questions." Whether 3I Atlas is the strangest natural comet ever observed or something that challenges our assumptions, it's succeeding in the most important way possible. It's making people care about discovery. Loeb wrote something powerful in that post. Science offers the privilege of maintaining our childhood curiosity and not pretending to be the adults in the room who know the answers in advance. That's the heart of this story. Not whether 3I Atlas is natural or artificial, but whether we're willing to ask uncomfortable questions, to investigate thoroughly, to remain open to what the evidence shows rather than what we expect to see. So where are we this morning, November 8th, 2025? We have new images showing 7 distinct jets emanating from 3I Atlas in multiple directions. We have calculations suggesting that producing the measured acceleration with such a complex jet pattern would require unprecedented mass loss for a natural comet. We have an alternative hypothesis involving technological propulsion that can't be ruled out by current data. We have mainstream astronomers correctly pointing out that natural explanations exist for each anomaly individually, and we shouldn't jump to extraordinary conclusions without extraordinary evidence. We have a viewing angle problem that makes it difficult to see whether there's a massive debris tail pointing away from the sun. And we have 41 days until closest approach, when optimal viewing conditions will finally let us see 3I Atlas clearly, measure its properties definitively, and settle the questions that have been accumulating since discovery. The debate between natural and technological origin isn't going to be resolved today or tomorrow. or next week. It's going to be resolved on December 19th and the days surrounding it, when hundreds of telescopes worldwide gather the most comprehensive dataset ever collected on an interstellar object. Until then, we watch. We observe. We gather data. And we remain scientifically curious about what this visitor from another star system might teach us about the universe. Your role in this, if you have access to an 8-inch or larger telescope, November 11th is your opportunity to contribute real scientific data. Look for 3I Atlas in the constellation Virgo before dawn, near the bright star Spica. It'll be around magnitude 10 to 11, requiring dark skies. Photograph it if you can. Note whether you see any tail structure. Report your observations to the Minor Planet Center. If you don't have a telescope, follow along online. The Virtual Telescope Project is hosting a live observation event on November 17th. Watch in real time. See what professional instruments are capturing. Be part of the global community asking these questions together, and subscribe to this channel for updates. When December 19th comes, we'll have comprehensive coverage of what the observations reveal. Whether it settles the mystery or deepens it, we'll be here explaining what it means. To everyone watching, thank you for engaging with science when it's uncertain and complicated. Thank you for being curious about 7 jets shooting out from an interstellar visitor. Thank you for asking whether they're ice or engines, and being willing to wait for data rather than jumping to conclusions. Keep watching the skies. Keep demanding evidence, and keep that sense of wonder alive. Because whether this is the most unusual natural comet in history, or something that rewrites our understanding of what's possible, we're watching it unfold in real time. December 19th. Mark your calendar. We'll know soon.